In our first drawing assignment, which is assignment 2, we're going to make a drawing of a spur gear. And don't worry, we will not be drawing teeth. Usually when you draw spur gears for some kind of design you're doing, you use what's called simplified representation. It's kind of like simplified threads on a bolt. So if you have a side view, you'll use an object line to show the profile of the gear. You'll use a hidden line there to show the root at the bottom of each tooth, and you'll use a center line to show where the pitch diameter is. Then in the circular view here, you use phantom lines for the outside diameter and the root diameter, and then you use a center line circle for the pitch diameter. So here's all of that summarized. Side view has object line, hidden line, and center line. Circular view has phantom lines and center line. You can draw a section view sometimes. I think these are examples out of our book. We don't need a section view because we don't have anything in our gear that we need to show there. You do need to include a data table of some form, and that is for the person who is going to set up that gear hobbing machine. Remember we looked at the Lin gear equipment and how they cut their gear teeth? They have settings on their gear hobbing machine where they plug in all this data that you give them, the addendum and the hole depth and the circular thickness and the pressure angle, and that tells the machine just how to cut those gear teeth. This is an old-timey example out of our book. So here, this is out of our book, I think. For some reason, this person actually drew the teeth and drew a section view because they have webs in here. I just wanted to show you the data table. Your drawing will have a data table with these numbers, not these particular numbers, but these categories of numbers. We'll look at that in just a minute. I'm just trying to get us organized a little bit. Here's our assignment that we'll be doing. So it says draw the spur gear, and we're going to make a simplified view of the spur gear. Use the phantom line circles and the center line circles and so on and so forth. The thing to know is that you'll dimension the features that are not teeth. So what size and shape was the gear blank before they cut the teeth? You'll want to dimension the face width, the distance that hub sticks out, the diameter of the hub, the diameter of that hole through the middle, and there is a chamfer on each side of the tooth, and here are the dimensions for that chamfer. You will want to include those in your simplified drawing. Then you'll want to include a data table to tell the gear cutting person how to set their hobbing machine. Let's see, was there something else? Oh yeah, and I wanted to mention we do have a keyway in this gear. They almost always do, but we're going to learn how to dimension that next time. So you can do everything but the keyway for now. And notice here's the material. It's an SAE high strength grade of steel 4320. Okay. So yours will be something like this. Here's the object line on the outside. Here's the hidden line, the center line. Here are the phantom lines and the center line. And notice how you're showing the hole through the middle and the diameter of the hub. Here's more or less what yours will look like. See those chamfers? So you don't want sharp corners on your gear. You're going to chamfer the corners. And here are the dimensions that you will put on your drawing. The thickness, the hub thickness, the hub diameter, the bore, the chamfers, and the keyway. Then you'll make a table. You can do what I do, which is just use lines and text. I know I'm not that sophisticated. I just draw lines and text and put the numbers in. AutoCAD does have a table function, and we probably should use that, but I just have never learned to use it. And then here's the table out of our book where we'll need to look up some formulas for numbers that we'll put in our table. So let's think about this. Does he give us the pitch diameter? No, he doesn't. Let's come over here and look at our assignment. So here's what he gives us. He gives us these numbers. There's no pitch diameter in there. So we'll need to figure out our pitch diameter. And this table says the formula is number of teeth divided by diametral pitch. Do we know the number of teeth? Yes, we do, 20 teeth. Do we know the diametral pitch? Yes, we do, 5. So, can we figure out the pitch diameter? Yes, 20 divided by 5. Looks like our pitch diameter is going to be an even 4, doesn't it? Okay, now what? Diametral pitch. Oh, sorry, addendum. Does he tell us the addendum? No, he doesn't. We'll have to figure that out. And according to this chart, the addendum is 1 divided by diametral pitch. Diametral pitch is 5. So your addendum will be 1 divided by 5. In other words, 0.2 or 200 thousandths. What about the hole depth? Does he give us that? No. So here is the formula for the hole depth. 2.25 divided by diametral pitch. So 2.25 divided by 5, that will be your hole depth that you'll enter in your table. And last slide. Circular thickness. Does he tell us that? No, you'll have to figure that out. And this table says the circular thickness is 1.5708 divided by diametral pitch. You might have noticed that 1.5708 is actually half of pi. And that makes sense because pi is all about circles. And the circular tooth thickness is a part of a circle. So here we've got something or other related to pi divided by the diametral pitch. And you'll find that number for the circular tooth thickness, and you'll put that in your table. All right. What else do we need to say about this? So you'll show 2 views in your drawing. You'll dimension the features that are not teeth, and you'll provide a table for the features that are teeth so that your person in your manufacturing facility can set their machine settings and cut all of this. Does he give us the pressure angle? Yes, he does. 20 degrees. All right. Now about visualizing this gear, I just wanted to show you this because it's nice. A student in an earlier year was learning to use AutoCAD's 3D, which is not the greatest 3D SolidWorks and Inventor are much better, but anyway, here's AutoCAD 3D, and he drew this spur gear in AutoCAD, and in 3D he put some dimensions on there. I just wanted to show you this so that you could get a sense of what those chamfers look like. Let me rotate this gear around. See those chamfers on each side of the gear teeth? What he did not do that you should do is he did not say 2 times. So this should be 2 times 30 degrees, and this should be 2 times 120 thousandths. And for your hub diameter, of course, you'll want a diameter symbol. So I think, oh yes, he also did not dimension the shaft diameter, that hole in the middle, and you will need to do that in your dimension drawing. Our book tells us that the shaft diameter is 1 1/8, so put that diameter in there. Be sure to put on the face width. And then next time, we'll stop talking about gears for a moment, and we'll come back and talk about keyways and figure out what size of keyway you need and how to dimension it.